All right, so I'm gonna pull my screen up. All right, y'all, so 9A deals with models, and it's called Modeling Our World. And we're gonna look at, in 9A, we're gonna look at functions, and they consider them the building blocks of mathematical models. So I'll say a good function in the real world is one where you can put one amount into it and it gives you one output, okay? Sort of like a paycheck function. If I was using my paycheck as a function, I would want to put in one time for my hours, and for the hours I put in, I'd want to get my one amount out for my pay. Okay, so a good function don't have choices. So technically a function, it's going to describe how a dependent variable changes with respect to one or more independent variables, to one or more independent variables. So let me use my paycheck as a example of these independent variables and dependent variables. If I was looking at my paychecks, the hours I worked would be my independent variable because I can work any amount of hours from 0 and up. Okay, so I can control the hours I worked. My pay, which would be my dependent variable, because the pay I get depends on what the value of my independent variable is, right? My pay depends on my hours I work. Does that make sense? All right, so when we only got two variables, they are often summarized as an ordered pair. Okay, so your ordered pair is going to come in parentheses, and y'all seen this if you ever graphed. It's got an X value and a Y value, okay? But your ordered pair, the X value is always the independent variable. And your Y value is the dependent variable. Okay, now I'll be refreshing you on graphing later on in this lesson. So in reality, the dependent variable is a function of the independent variable. Okay, so what that means is I take my independent variable, I do some kind of math to it, and I get my dependent variable. Once again, with my pay, I take those hours I worked and I multiply by what my pay is per hour. So I do a little math there, and it gives me my dependent variable or my output. Okay, so if X is the independent variable and y is the dependent variable, we write the function as y equals f of x. All right, let me let one in real quick. All right, so in college algebra and in math, this is what we call function notation. F is usually what would be the name of the function. X is your independent variable. And Y, like we said, is our dependent variable. Okay, so remember, it's always the independent variable that's being hit with the function. The Y is where we're always going to put our dependent variable. So this variable depends on what we put into the function from those independent variables. All right, so I'm going to flip my page if y'all got that. All right, so ways we can represent functions. So representing functions. And y'all, there's actually a homework example asking you these three things, okay? First way I can represent one is I can use a data table. Hey, that'd be some of the things y'all did in class earlier when we was finding out our relative frequencies and stuff. We were making up tables, okay? So we've done that in the class. Second way is draw a picture or graph. So I do a lot more graphs than I will pictures, I'll put it that way. Okay, but we can represent functions using a graph. And then the third way is we can write an equation or formula. So write an equation or formula. Now they try to trick you up on that homework and put words like expressions. Expressions are not equations, and we don't represent a function with an expression, okay? So they'll try to trick you up on that, but you want a data table, graph, equation, okay? So since we're dealing with functions, we need to learn about two key words, domain and range. So the domain on a typical graph would be all the x values. So it's going to be your x values, which is also the independent variable. Okay, which means our domain is going to consist, of all values of the independent variable. So y'all, if you were plotting this on a graph, Your domain would be any values going along your x-axis, okay? And usually an x-axis is going to be some kind of time, like days, years. But you'll see in our examples, we will write our domains on our x-axis. Our range, in graphing your range, is your y values. They correspond to the dependent variable. Okay? Which means our range is going to consist of all values of the dependent variable. Okay, now, what those ordered pairs did a while ago, when we looked at an ordered pair, we had our independent variable and our dependent variable. I can use ordered pairs to represent different points on the lines that I get, okay? Now, if the range is the y values on your graph, it's going to be the vertical axis, or often called our y-axis, okay? And that's what's going to make up the graph. You're going to have your horizontal x-axis and your vertical y-axis. So here's some tips on creating. So creating and using graphs of functions. Okay, so let me see. I got about 4 steps for this one also, okay? So step 1 on doing a graph on this, identify the independent and dependent variables. And remember, variables are just the quantities that you're comparing on these, okay? Step 2, once you know what your independent and dependent variables are, you're going to identify the domain and range. So identify the domain and range. Okay, if I'm comparing something over time and I'm looking at yearly totals, I don't want to do every year from the creation of time till now. So I might start at a year like 1990 and go till 2020. Okay, I don't want to look at 2,000 years worth of data when I'm only interested in what's happening now. So you want to identify your domain and range so you know how to make those X and Y axes, okay? The next thing we're going to do, we're going to make a graph using that data. So make a graph using the data. You know, like, what if I was looking at how heavy a car was and its gas mileage? You know, the heavier the car, then you're thinking maybe the gas mileage will be lower because it's a lot more mass to pull and stuff, okay? So if I'm looking at gas mileage, I'm probably going to be thinking anywhere between maybe 10 to 50 would be a good range for those kind of values, right? 0 seems irrelevant and not many cars are going to get more than 50 miles a gallon, you know, so you're going to think about things in the real world when you make them graphs, okay? And then really the last thing, does the data make sense and match what you thought? So does the data make sense? You know, if I'm looking at heavier cars giving me lower gas mileage, but I'm getting high results for the gas mileage instead of low, then I might would question my data, you know. So you always got to be thorough when you're looking at your data. So y'all, before I do, I'm going to go through some of the examples on the homework in here, but I wanted to refresh y'all on graphing. So I'm going to make me a little X and Y graph here for you. We'll call that our X-axis and our Y-axis. And I'm just going to go by ones on this. 3, 4, that'll be 5, 6, 7, 8. And I'll go negative. And then the same thing up. So 5 up, 6, 7, and then I'll go down. So technically graphs go forever in either direction. In the center of this graph right here, we call that the origin of the graph. So the origin is the center of the graph. It has coordinates. Coordinates are our ordered pairs. And remember, it's always the coordinate for the independent variable and then the coordinate for the dependent variable. If you're right in the center of this graph, your coordinates would be 0, 0. Now, on the x-axis, you get negative going left. -1, -2, -3, -4, -5, all the way towards what we call negative infinity. To the right of the y-axis, the x-axis is positive, and it goes up by 1 towards what we call positive infinity. This y-axis, the vertical one. Here's the x-axis. Above the x-axis, the y values are positive, and they increase by 1, headed towards positive infinity. Under the x-axis, these are negative values, and they keep decreasing by 1 towards negative infinity. So x-axis, right positive, left negative. Y-axis, up positive, down negative, okay? Now, technically, you got 4 quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. But what I want to get y'all good at is plotting points, because there's a few homework problems where you got to be able to plot some points. So I'm going to show you how to plot points. So I'm going to plot my point first. I'm going to plot a point 2, 3. So y'all, what I do when I plot points, I always start in the center of my graph. The first number tells you to go left or right. Second number tells me to go up or down. If the first number is positive, I'm going to move right 2. So since that 2 is positive, I'm going to go right 2 units. So from 0, I go right, but don't put a number yet. Just sit there a second. Because what we're going to do, we're now sitting at 2 on the x-axis. Since this 3 is positive and it's for the y value, that 3 being positive wants me to go up 3. So from that point where I went on the x, I go straight up 3. So 1, 2, 3. Once I stop there, I'll put my point. So Positive, you go right. Positive, you go up on that second number. Okay, so now if you notice, if you drew a line down, you'd be on the 2 on the x-axis. If you drew a horizontal line, you would be at 3 on the y-axis. Okay? So anyone got questions on that plotting? I'm about to do some more. So I'm going to throw a negative at you. How about if I had a 5 and a -2? So I'll still start with the first number, and I'm going to start in the middle again. So since that's a 5, that means I'm going to move right 5 from that 0. So go right 5, and you'll be right on the 5 on the x-axis, which all this 2 is negative. So when the y value is negative, that means we're going to move down 2 units. So we're sitting over here at 5. We now move down 2 units. So there's 1, 2. And I put my point. Okay, so just bringing back memories, I hope, from somewhere in life, right? All right, so let's try this point right here. Let's try a -2, -2. So both my numbers are going to be negative this time. So starting in the middle, when the x is negative, I start in the middle, I'm going to go left 2 units. So I'll be right there at -2 on the x-axis. So we went left 2. So we're sitting right here at -2. The y value is -2. So remember, on y values, when they're negative, you go down. So from that -2, I would go down 2 and then put my dot. So 2 left, 2 down. Okay, so y'all check this out. Anytime they're both positive, you're going to be in this section of the graph with your dots. When they're both negative, you're going to be in this section down here with both your dots. This one I got here from having a positive and a negative. And then to get over here, my x would have to be negative, but my y would have to be positive, okay? So I'll show you the signs. To be in this one, both numbers are positive. To be here, negative x's, positive y's. To be in number down here, both of them will be negative. And then to be here, you'll have a positive x, negative y. So when you're starting out, if your signs are in these orders, that's what they're going to be at when you're done plotting them, okay? Now, I'll say this, for Thursday night, I'm going to start out doing some support help with you on slope and y-intercept stuff. So we'll do that before we actually get into the other lesson on that, okay? I think that's 9B, support, and then 9B. All right, so I'll get into more graphing on this homework if it asks. So let me change these pages. All right, so here's another example like on your homework. It wants me to write a short expression or write a short statement that expresses a possible relationship between the variables. All right, so they're basically giving me an ordered pair, and this one says volume of gas tank. That's my independent variable. My dependent variable is my cost to fill the tank. So I'll tell you what they mean by this, and then I'll do some more of these and see what y'all do with them. Yeah. All right. So to me, what this is telling me, that a relationship that's possible between this, to me, means as the volume of a gas tank increases. So y'all, the bigger your gas tank increases, well, what do you think that's going to do to the cost to fill that tank? As the volume of gas tank increases, I would think the cost to fill the tank also increases. So they just want to come up with some kind of relationship you think they might have with these kind of variables, okay? So that makes sense, right? The bigger your gas tank, the more it's going to cost to fill it, right? All right, same thing, okay? This one has weight of a car, average gas mileage. So you would think maybe on something like this, weight of the car is my independent variable. So cars can weigh anywhere from probably 1 to 2 tons or so, 1 to 5, 6,000 pounds maybe. So I would think that as the car increases, the average gas mileage is probably going to decrease, right? The heavier the vehicle. So as the weight of a car increases, the average gas mileage decreases. All right, so let me see if y'all can see this pretty good, or do I need to zoom in? Let me zoom in just a little. So this is like one of y'all's homework problems. So we're going to identify the independent and dependent variables and describe the domain and range. So
I have a question.
Yeah, I hear you.
I have a question. I did this homework already, but I'm gonna let you go ahead. But I got one wrong for from the domain and the function in years, from the minimum value to the maximum value.
Okay.
But I thought I was right.
Okay. So I'll show you that on this, what they're looking at on those. Okay, Ivory?
Okay. Okay.
So,
Okay. Thank you.
So the independent
Okay. Thank you.
variable on this is going to be, so your two variables over here says what, world population in billions, and this is your years.
Yeah.
So the independent variable is going to be the years because that's on my x-axis, right? So the years is going to be our independent variable. And then the population over here is the dependent variable because the population looks like it depends on what year it's in, right? So population over here. So you'll put them in. It should ask you to check that answer or not. Now, the domain of the function is the years, because remember the domain is the same as the independent variable. So that is the years from a minimum value. So on the years, you see the first dot on this graph right here? You got to start right there with your domain, okay? You can't start over here at the 0, although there's a 0 on that x-axis. You got to find out what's the x value of that first point. And if I look at that, what does that look like? 1950. So my domain, whoops, I think I wrote that on the wrong area, y'all. I'm doing my domain, so years should be up here. Somehow I skipped. So I'm doing domain, remember. So domain is the years. It has a minimum value of 1950. So the year 1950 is my lowest year on my domain. And then it says it has a maximum value. So we need to take this last dot and see what that year is corresponding to it. And that looks like 2000. So my domain is going to be from the years 1950 to 2000. Okay? You don't want to start at the 0, and if this went further, you wouldn't want to go there. You're just looking for what parts does your graph hit. Okay, I hear you.
Okay, I wrote that in when I made that answer. It marked it as wrong, being wrong.
Okay, so what I'll do is I'll get in
everything
there.
else right on that question except for the.
Okay, so I'll get in there and I'll look at it because it'll let me pull your stuff up, and I'll see what they was doing on it. Okay.
Okay.
All right, so on this one, so the range we said is the same as the dependent variable. So the range, this needs to be population, because that's my y-axis. So my population, which is my range, has a minimum value of, so we need to go from that first dot and see what that is on the y-axis. And they got the billion here, so all we want to do is put the number since they already got billion. So that looks like I'm at what, 2 billion for my minimum? And the maximum is up here at the last point. It's the highest y value. And that one looks pretty close to 6. Now, it wasn't quite at 6, but notice what it says here. Round to the nearest integer. So since I'm rounding that to the nearest integer, I would make that a 6. If you try to put a 5.8 or 5 point something, it's definitely going to mark that wrong at that point on that one, okay? So let's see what one of these answers we had put. The function shows a steady increase in population from 1950 to 1960. The function shows that there has been a relatively constant world population since 1950. That is definitely wrong. If it was constant, it would be a straight line going straight across, and every year would be 2 billion. Okay, so constant would be it stayed the same, which it don't. So we know it's not B. The function shows that the rate of increase in population has been increasing since 1950. Well, no, that don't look like it's going up really drastic to me, does it? Actually, it looks like it's pretty steady increase, right? It don't have much of it. It's almost a straight line, and anytime something makes a straight line, that means it's pretty steady, okay? So it ain't that. It shows an initial increase in population, but then a decrease in population closer to 2000. Well, y'all, there's not really no dips on that. All these are going uphill from left to right, so we know it ain't D. So it had to be what? A, which we said it was steady. It's a steady increase, so you would go with A on that, okay? So these aren't bad. It's just looking at these and trying to figure out what they want. Same thing here. We're going to identify the independent and dependent variables and then describe the domain and range. And then make a clear graph of the function. So we'll just pick one of these. Okay. So when they're in this order, the first column is going to be your independent variable. The second column is always going to be your dependent variable, which means this column is my domain. This column will be my range. Looks like they're in order from small to large on both sides. So let's see what we're going to do. The independent variable is the speed. And the dependent variable is the stopping distance. So it depends on how fast you're going to how quick you're going to slow down, okay? The domain of the function consists of all the, see where we're at, speeds, from the minimum value of on my speeds is 10 to a maximum value of 70. So y'all seen that's two of the forms of representing my functions, right? While ago I had a graph. This time we actually got a table of the values. All right, so let's go on to range. Consists of all the stopping distance. A minimum value of 16 feet to a maximum value of 329 feet. So they're saying on average, if you're going 70 miles an hour, you're going to need 329 feet to get it stopped. Okay, if you're going 10 miles an hour, stopping distance is 16. And see, they're saying that's your reaction plus braking in feet, okay? All right, so we want to make a clear graph. So remember, my independent variable has to go along the x-axis. So my speed will be on the x-axis. My stopping distance will be the y-axis. Okay, so looks like they're breaking this in by tens, 10, 20, 30, 40, 50, 60, 70. So I'm going to go from 10 to 70. And then y'all from 16 to 329, looks like over here on all my pictures, they went from 0 to 350 up here. Okay. So at 10, we were at 16. So 10, 16 would be fairly low on that. At 20, I'm at 45, which is a little higher. 30, I'm at 72. So I just wanted to get a rough idea of what was happening. Now, these ain't exactly straight lines because these don't have the same distance between all these points. Notice, these values up here toward the end are a lot bigger in between than these values up here at 10 and 20 x values, okay? So our graph is really going to start wanting to curve up eventually. So we got a choice between B and D. But notice, B they don't have speed for the x-axis. They got speed for the y-axis. We need to go with D. D has the speed for the x-axis. It has the stopping distance for the y-axis, which is what we needed. Okay, so and remember, it's not this one because that made a straight line, but all these don't have the same distances to make that a straight line. So you need to go with D on that one. And then once again, it's going to ask you this. So it shows a constant rate of increase. No, because constant would be a straight line. The rate at which the stopping distance decreases grows faster as speed increases. Well, these stopping speeds, they're not decreasing, they're increasing. So the rate at which the stopping distance increases grows faster as the speed increases. Definitely, because when my speed was up here at 70, the gap from 60 to 70 was almost 100 feet in itself. So go with C. And then the rate at which the speed increases, no, because the speed don't depend on the stopping distance. The stopping distance depended on the speed. So this one, they're just trying to flip around but the speed don't increase because of the stopping distance. The stopping distance increases because of the speed. So y'all watch for them to try to switch that order on you, okay? So y'all got a question on that one, any of you? They're pretty straightforward once y'all get used to what their domain and range are. Let me see if there's any more I wanted to do.
Mr. Rutherford, I had a question.
Yeah.
So now with the classes online only, with the projects that's going to be emailed.
Yeah, I've gotten 2 through email already, so that's probably the best way. Just email it to my email address. And what I'm doing, I'm just taking them, printing them off, going through them, and then I'm putting grades into the math lab. So yeah, that's, and I couldn't get the link in Blackboard to work. And I tried again this weekend to get that one fixed, and it's still not letting me get into it. So yeah, just send it in my email, a Word file or a PDF, and it'll let me go through it and read it and stuff. So, and y'all remember that ain't due till the Sunday that we go on Thanksgiving break. So not this coming up Sunday, but the next, okay?
So I had a question on that too.
Yeah.
I was wondering about, so whenever we're doing the loans, like I looked up the loan for my car or whatever, and I was wondering, do we do our math based on like the 36 month? And then, because I was looking at, it's like the one that I found was like a 20% down payment. And then is that with 36
Yeah,
months?
you can do it like that.
Not real sure how to do it.
And then you just want to look at different options, like a 36-month loan versus maybe a 48-month loan versus 60 or even higher. They should give you like different rates on the websites. Yeah. But that'd be perfect. You can put anything down on it to get your loan if you want to. Okay. It'll probably help out a lot putting money down on a loan. Especially if you can usually get like 20% of it, that helps out a lot.
Yeah.
All righty, y'all. So really, that's about it. But I will say, my next class, have y'all ever seen this kind of equations? Y equals mx plus b?
Yeah. No.
So m right here. So this is My X and Y are these points right here, the X and the Y. But the M in here, M is the slope. And we'll look at this. B is the y-intercept. And really the y-intercept to me is just the starting point. Slope is how you get from one point to another. So we don't have to know this formula, but I'm going to show you how you get the slope. The slope, which is the little m, is you take the difference between 2 points, and that's over the difference of the x's. Y'all have heard of y2 minus y1 over x2 minus x1? Been a while, right? But all y'all going to have to know for the next class is how to look at one of these equations and find me the slope and the y-intercept. Okay? So let me show you. So if I had an equation like y equals 3/4 x minus 2, and they want to know the slope and y-intercept, the slope, which we write as a little m for this line, would be where I had the m in the equation, which was right in front of the x. So the slope is always the number in front of the x. So this slope would be 3/4. My y-intercept which in that formula walk I had as a b. So remember, we're still doing y equals mx plus b. The y-intercept is -2. But y'all, we got to write it as an ordered pair since it's a point on the graph. So anytime you have a y-intercept, its x value is going to be 0. And then the y value will be the -2. So the y-intercept has to be written as an ordered pair in MATLAB when we start doing this. Slope, notice, is in fraction form. Okay, so let me show you one more. So once again, I'm going to find the slope and the y-intercept. And then I'll go over this stuff real good on Thursday with you. But the slope is the number in front of the x again. So that means this slope is a -2. The y-intercept is the number at the end, 5. But remember, I got to write it as an ordered pair. So that would be a 0, 5. So y'all, here's something nice. You see, this is a positive slope up here. So positive slopes go uphill. So what that means is this goes up 3 in the y's and goes over 4 on the x's. 3 in the y's over 4 in the x's, because both these numbers are positive. This one has a -2. That means this line is going to go downhill. It goes downhill twice in each y value and over once on the x's. So down 2 over 1. Down 2 over 1. So if your slope don't look like a fraction, remember, there is always a 1 on the bottom, okay? So y'all, we're not going to get deep in slope. I just wanted to sort of show you what was going on with the uphill, downhill based on the signs. All y'all are going to have to know is how to pick them out and write them in MATLAB as the answers, okay? So this one I'd actually write as a -2. All right, so my last question before I let y'all go. What are the 3 ways?
I have one.
Okay.
From the top question, from the y-intercept, is that a 6 or
Oh, right here?
that yeah, the
That's a
intercept
B.
Plus that's a
right.
B, right?
That's a B.
So okay, now why was that a B? I missed that.
That's just a symbol they use to
Okay,
represent.
that comes up from that equation. Okay, great. I got
Yeah,
that.
it's just a symbol
Okay.
they've come around with to represent it as
Okay.
mhm. So here's my question. What's the 3 ways to represent a function?
Use data table,
Data
draw a
table,
picture or graph, and write an equation or formula.
picture or graph, and then equation or formula. There you go. Well, let me write that down just a little bit. So equation or formula. Because that's going to be your first question probably on your math lab homework, okay?
Yep.
All right, y'all. So that's it. We're going to be we got a lot of time and not a lot of material left. So we're going to be doing a lot of reviewing and just trying to mosey through instead of rushing, okay? So we're at a good spot right now. So actually, we were a little ahead, actually, from what I had on the homework dates. You know, because we actually did the 8A the other day, and that wasn't due till this week. So if you haven't done 8A yet, you're good to go because it still wasn't due, okay? So, y'all, questions? Anybody?
Good.
So, unfortunately,
I've
we're
got
going
one.
to have to be virtual the rest of the year if you just joined us. The school for most of your classes will probably be virtual after Friday, unless you're in a tech field like dental or one of the cooking schools or welding or something that you need hands-on. But listen, if you use the library or you need financial aid or advisors, they're going to be there for you still, okay? The college is not closing down. They're going to keep it open. We're just going to have to follow all the mask stuff and stuff, okay? All right, so let me stop recording this. And I'll get this uploaded. Should be about an hour or so, but I can get it into YouTube and send y'all a link.
I had a question before we go.
Yeah, I got you.
The domain function, or the domain. No, I got the domain. It was I don't know.
Are you doing Are you doing a problem in MATLAB?
Yeah.
All right. You see a button right? Hey, you see it where it says share on your screen?
Yes.
Click that. Click share.
Okay.
And then you should see the screen containing that homework problem.
Okay, so is this me or you?
Yeah, I'm seeing it now. Okay, I see 9A, so.
All right, so I've got, this is not the one I have an issue with. The one that I have a problem with is, okay.
Yeah, pull that down and it'll pull hit that arrow down right there. Yeah, hit that arrow down.
Yeah, it's not working.
Oh, okay, because it should pull them all up, all your questions, but. All right, this one's got a miss.
I keep having problems with this one, the year, and like choosing which one is which, because I chose population, and so the end of, and then the, I don't know, I don't really get it, any of it.
Okay, so do this for me. Slide that screen left for me, because I'm being blocked by my Zoom stuff.
Yeah. Help?
Now, hit similar question.
Okay.
And it should pull us up a new question for you. All right, so the independent variable is the x-axis right here. So we got years on your x-axis from 1950, 60, 70, 80. So that's going to be your years.
Okay.
And then your dependent variable is going to be your y-axis. And that is your, what's that, population? All right, so check that one.
And
So the
I've got,
domain, so remember the domain is
is it,
down here. It's the same as your independent variable. So your domain is going to be your years. Oh, fix that. Remember the domain is the independent variable down here. Domain
okay.
is your X values. So remember, it's always going to be this horizontal. So there you go. So what's the minimum one over here? It looks like what, 1950? And then
Yeah.
your maximum
It's
years
19,
is going to be right here at
2000.
2000.
Yeah.
So hit that and it's going to do the range next, I bet.
Range.
So the range is
So,
these Y values or this vertical stuff. So that's now
okay.
going to be populations. So it's giving them in billions and they want us to round to the nearest integer, which is whole numbers. So go with that 2 like you got, 6 like you got, okay.
Okay. And then,
So let's see what it says. It shows to me as my years increase, my population's increasing, but it's a steady increase. It's almost the same from every point to another. So that one's steady because see, this one says the rate is increasing, but if the rate was increasing, it would sort of want to curve like those exponential graphs we did that day. Remember how they were really curvy?
yeah.
And then it don't show a decrease at all, so it can't be that last one. And like we said, it's not constant because constant would mean it would be 2 billion the whole way across it. So, all right, so let's see what's
So I guess
next.
so I got this one. No, I didn't. So
Now, remember
I
ours.
got I got these two wrong.
Oh, is this a new problem?
Yeah, this is a new problem.
Okay, so let's see what we got here.
And so, how do I identify the?
So the independent variable is going to be the first column. Dependent variable will be the
Y.
So this is like your X's over here and your Y's. Because notice the stopping distance depends on how fast you're going, right? That makes sense? Since the stopping distance depends on how fast you're going, that makes it my dependent variable. So go with speed is your, there you go, you was right. Is your, and your dependent variable is the stopping distance. So you got to figure out which one depends on the other. But they usually give you, the X is usually your first or your domains, and then the second one will always be your range. So the domain is all these speeds over here.
So I've got this written down on the domain. Okay.
Mm-hmm. And you're just going to go
all the independent variables.
Mm-hmm.
Okay.
So those are always going to match up. Whatever you put here for independent has to be the same for your speed, your domain stuff. Yeah, you're good on that. 10 to 70. All right, so let's see what you got here. The range, definitely. Distances. Yeah, I can't tell what is. Yeah, there you go.
Okay.
Now remember, ours is going to increase as our speeds increase. So watch the bottom because this one's backwards, right? It's got distance and speed. That one's constant, but notice you don't have the same gap in between each of these. There's like 24 distance here, 30 distance. So these are going up a lot higher. So look at this. Oh, you got it right there, D. That's it. Because I didn't see you had, I thought you had to, no, you're good. So you just got to sort of see, are they sort of going the same or is it a lot quicker? Let's see here. So it said the rate at which the stopping distance increases grows faster at, oh, well, that looks like it right there, don't it? Where you're hovering on? Because this one's decreasing, what ain't decreasing. And then this was doing distance to speed was constant, which it would be a straight line again.
I can go back to that. So this is what it was.
Mm-hmm.
So
good. So it looks like you just got one more to go and you're done.
Yeah, I just had a hard time figuring out which my dependent variable was and my independent variable, because whenever I wrote down on your notes, I just wrote down, X is dependent. Well, I mean, yeah, X is independent and then Y is dependent. So that's all I wrote down. I didn't really understand how to determine which one's which in like a word problem.
Right. So that picks you up though?
Yeah. Yeah, I
Okay.
think so. Okay.
So y'all
All right,
gonna be here, so y'all be here Thursday, right?
Yep.
Actually, in class, no, we're not doing actually in class, right?
We can't do it in class no more, so
Okay, so no. All right.
we'll be zooming for the rest of the way, y'all. So, but do like y'all did tonight. Participate and ask questions like y'all are doing, because that makes it a little better and not as monotonous for me.
Right.
You know what I mean?
Well,
But
so I just-
one thing, you were right. I get it wrong. When I looked at how you did the graph, I used the distance instead of using speed. I wrote it backwards.
Okay.
I rechecked my answer because
Uh-huh.
I'm looking. I said, why did I get it wrong? Because I knew what it needed to be, but I
Right.
didn't read the bottom of the graph. I just looked at the graph
Okay.
and then I marked it. But I made it wrong. So
Okay, that's cool.
you were right, because I'm looking. I
picked
said, then when I listened to you when you said speed and distance, so which was the domain, which was the range. So